Redbend has seen the convergence of mobile into other industries such as consumer electronics and automotive. So many more devices are now being connected to the internet, are connected to the network. They're benefiting from additional use cases, additional revenues, and also taking advantage of that connection to improve their maintenance, improve their efficiencies, using over-the-air updates of the firmware of the devices and of applications on those devices. And it can be a wearable, a watch, glasses, it can be the car, it can be the in-vehicle infotainment, the rear seat entertainment. There's many parts of software now which are now connected to the network, learning from the mobile industry and seeing what they can learn, what they can benefit from the mobile industry. This is where we're coming in. What Redbend are offering this year is not just core technology, but a complete over-the-air updating solution where the manufacturer of whatever it is they're building can not only update their devices but manage the software on their devices throughout the life cycle of that device. One of the things we're seeing in industry is not just Redbend looking at the convergence of mobile and automotive, but also the operators. Many of the operators are seeing how can they leverage their existing infrastructure to additional adjacent markets. A very good example of that is AT&T, who are a very big OMA DM based device management infrastructure for managing mobile phones and tablets, and they're looking to manage automotive and the car industry as well. They've started a drive studio where they're showcasing all of their latest technologies their partners are bringing towards the automotive industry using the AT&T cloud. And Redbend have just announced, together with Qualcomm, that we've been introduced into the AT&T Drive Studio to really showcase how our software management solution, our over-the-air updating service, sitting on the AT&T cloud, can then be used to manage devices, manage cars in the automotive industry. In fact, one of the customers I met yesterday, one of the big automotive manufacturers, they said that their existing systems are for managing parts. They manage a brakes system, they manage a fuel injection system, they manage a steering wheel and a gear shift. They're having a hard time understanding how they manage the software as a separate element of the car. They accept there's a lot more software in the car. They accept that software has versioning, which is very different than the hardware parts in the car. They accept that software has dependencies, and they're trying to understand how they can manage all of that. What we and AT&T have suggested is that there is an existing standard available, which has been tried and tested in hundreds of millions of devices around the world, the OMA SCOMO, the Software Components Management Object, which is perfectly suited for managing software in different versions on devices that have many different components, such as the car. And this message was actually very well accepted yesterday from this huge manufacturer, who said this is something they want to investigate because this could solve their problem of managing software in the car. More and more people realise that when they get in the car, it's not about the car anymore. In the past, when people would buy a car, you'd maybe pop the bonnet, have a look on what's underneath the bonnet. Now people get in the car, the first thing they look at is the in-vehicle infotainment. You know, how big is my digital screen in the car? It goes so far, the Tesla, the new electric car from California, has got a 17-inch screen, so who knows where that's going to go. But it's about the software, and even the consumers realise a lot of it is about the software. The heads-up display, the rear view cameras, the sensors around the car. What we're showing here is an example of that. This is a digital cluster where some of the speedometers and the rev engines now are all being designed on software based. This is the in-vehicle infotainment, your music, your mapping, the TV. I've been in taxis in Korea where they watch the TV as they're driving. Over here we have an example of the ECU. These are the part on the top here is the small electronic control units that go into the car to manage the temperature in the car, the tyre pressure. There's about over 100 of these in some of the high-end cars today, and of course this technology is seeping down into mid-range cars and lower. So being able to manage all of this software is a challenge. It's not just a challenge because you have a lot of software that needs to be managed, it's also a challenge because there's many different types of hardware running many different types of software. So this is an Android operating system, it's a real-time operating system, this is a Linux operating system, this is on a TI board, it's on a Freescale board, etc., etc. But one of the things that SCOMO can do, it breaks the line between managing the protocol for managing the device and actually what is being managed and how it's being managed. So the SCOMO can still say, look at the car as a single device and say, manage each of these components, do firmware updates, application installations, application removal, etc. And the technology that actually performs that is separate from the protocol. So this is where the OMA DM and SCOMO of the OMA DM comes to play in a very strong way. When talking about OMA DM, there's two parts to it, of course. You've got the client side, which in most cases we're seeing is either sitting on a head unit, a powerful computer that's in the car, or maybe on a connected mobile phone, which is then supplying the connectivity to the head unit. So depending, some cars have embedded connectivity, some cars rely on the mobile phone to supply the connectivity. And then it's connecting back to a software management center, where this is a center which is either run by the car manufacturer maybe, or by the tier one, or by the operator who could be hosting it, such as AT&T, but then still managed by the manufacturer. So using the software management center and the standard connection between the software management center and the cars, the software can be updated. A final thing to point out is that software is managed in 5 different places in the car. It's managed on production line, where the parts they receive need to be updated before the car ships. It's managed on the docking station, where the car is being left for a few months before it ships to the customer. It can be managed at the dealership, where it has to be updated as a part of the yearly tests. It's managed as a part of a fleet for an enterprise, and even managed at home. Tesla have been performing firmware updates while the car is at home in the user's garage. So there's many places where in the ecosystem of the car, in the life cycle of the car, when over-the-air software management is going to become beneficial.